Okay, so what we are doing is going to be 4.3, y'all, which is properties of logs, just to be able to refer to them after, like, you know, you change your page and stuff. I've written them over there. The first thing is the way that you can use exponential functions as the inverse of logarithmic functions. I should have put a double arrow, right? Because you can go back and forth, honestly. And then the next one that is written is going to be our product rule. Then after that is our quotient rule. Then after that is a power rule. There are similarities to like the exponent rules that you should know by now, right? So we'll do a rule, a few examples, rule, a few examples. After that, there is a change of base property that, like, I think there's only a few problems on your homework that deal with the change of base property. I'm going to show you the way to do it. And it's usually going to tell you to use that property, right? Because if you were to try to change it into exponential form, you'll notice this exponent is going to be a crazy decimal. We don't have a way to find that. So what we'll do is we'll use our calculator. So it'll be like an approximate answer. That's that top right form that's up there written on the board. But I'm going to write it here also, okay? So 4.3. This is properties of logs. Okay, so the first one that we're going to do is going to be our product rule. This just states that if we have log base b, right? So that's saying there is a base there, of course. It can either be a number, a variable, or if there's none, right? That's when we know it to be 10, correct? Okay, and then like in parentheses, it might not always be in parentheses, but in parentheses, you have like m, n. Y'all, the fact that those are touching implies multiplication, right? There's not an operation in between them. That's m times n. That's 2 times x. That's 7 times 12. That's multiplication, right? I don't have enough room to write here, so I'm just going to bring it right here. What you can do, maybe it would be more appropriate to do an equal sign, y'all. And there's a reason why. I'll say it after we write it down. What you do, if you see that multiplication, you can apply the product rule, which is taking log base b of m and adding to it log base b of n. So that's similar, right, to the exponent rule? You got a to the m times a to the n. You kept the base, right? And then you added the powers. The similarities there is the fact that we're adding them together. If you see multiplication, you can individually add them, right? Taking the log of both. So let's do, I've got 4 examples here. Our first example is log base 2 of 2x, 2 times x. Y'all just have to make sure that your bases, your exponents, right, they're little. It's very, very clear that this is not just like a normally written number 2, okay? So using this, I see that those are multiplying. Because those are multiplying, the answer to a multiplication problem is a product. You can use the product rule. All it said is to individually take the log of each term and like add them together. So just follow this form. This would be log, my base is 2, right? Of, those are 2 different things. It's a coefficient and that's a variable. So just use the number first. So it's log base 2 of 2 plus log base 2 of x. So your goal is to recognize what rule can I apply? And then like, let's individually look at them and see, is there a property there? Can I actually evaluate it? And then you'll come to your final answer. So this is saying what? 2 raised to the what power equals 2. And what would that be? 1. So that actually can be evaluated and can be turned into 1, right? Then we have plus. Okay, this is saying, right, using everything we did on like Monday and Wednesday, this is saying 2 raised to the what power equals x. There isn't anything that we have mathematically to raise that 2 to equal x. So it just stays the way that it is. Like I actually can't evaluate it, right? I can't simplify it. So your answer is 1 plus log base 2 of x. A question I got in my last class was, how can I put this into my calculator to figure out the answer, right? Our calculator buttons, the natural log was base e, right? And then the common log, just the log, was base 10. We don't have a way to evaluate base 2, base 8, base x, base. Do you see what I'm saying? So that's why you need to know these properties and you're doing them by hand. Second problem, say we have log base 4, and then in parentheses, they have 7, and then like the multiplication symbol, and 5. Y'all, it could be written 7 open, 5 close. You see what I'm saying? It's just saying 7 times 5. Apply the rule. That's multiplication going on inside of there. I can individually take the log of both of those terms and I add them together. So I get log base 4 of 7 plus log base 4 of 5. By now, the goal is that you can look at this and know there's nothing you can raise 4 to get to 7, right? If you do fractions, you're going to continue to get smaller and smaller. If you do a number like 2 or 3 or 4, you're exponentially, right? Because it's an exponent, getting larger and larger and larger. So it is just this. And then same thing here. I can't raise 4 to any power and get 5. So that just ends up being your answer. Knowing the rules keeps you from like going down a rabbit hole. Oh, let me try this. Oh, let me see that. And then like you're just confused. Okay. Third problem. Say we have log base 2. And then in parentheses, we have x, y, z. Do you agree? Inside of those parentheses, it's all multiplication, right? Everything's touching. There's no operations. That's x times y times z. I can do the product rule, which means to take the log of whatever base you're in of each individual thing. And what you're doing is you're going to be adding them. I'm going to write kind of skinny, y'all. Log 2 of x plus log 2 of y plus log 2 of z. And we all know I can't raise 2 to any power to get x, y, or z. So that's just your answer. Okay. But do you see how once you kind of apply this, whatever rule you can, you kind of look at it individually now and you think, can they change into something else, right? And no, they can't. This is it. I'm going to try to remember to square all of my answers, but I'll probably forget, just so y'all know. Just kind of room-wise, I'm going to go ahead and switch pages. We have one more example using the product rule, okay? I feel like my knees need to pop. Okay, fourth example. Say we have log. There's not a base written. So that's that common log, right? We're just implying we know that it's 10. In parentheses, we have 100 x, y. So now what we do, that's all multiplication. We're going to take log base 10, right, of each individual term. I'm going to say now, applying the product rule, if the problem doesn't show the 10, when you go to actually like expanding it and you know what I mean, like adding all of them, go ahead and write your 10 because there's going to be a couple of spots where it just helps you solve it, honestly. So like when I take log, this is base 10, right? When I take log base 10 of 100, do you see what I mean? Having those two numbers right there, that should make it a lot easier to evaluate that. Now, oh, why'd I do that? Plus log base 10 of x plus log base 10 of y. Evaluating log base 10 of 100. I know that this is saying 10 raised to the what power is 100 would be 2, right? Because 10, whatever your exponent is, that's how many zeros you have like in total. So literally, that just turned into 2. Now, whenever you look at your log base 10 of x and your log base 10 of y, those can't change. Your answer for me, honestly, you can include that 10. It's not a problem. I don't know if the homework might be like, oh, you don't need to do that. I don't care. You could keep it as log base 10 of x plus log base 10 of y. Or your answer could be 2 plus log x plus log y. Those are equivalent. Those are the exact same thing. Okay, it doesn't change your answer. You need to show me that that's base 10. If anything, you're letting me know you know that's base 10, right? We can only evaluate that one though. So that's the product rule. Okay, so if in a problem you see things multiplying together, what you do, oh, wow, I'm trying to make that go away. What you do is you take the log of each term, adding all of them, okay? So now we're gonna do the quotient rule. So the answer, technically I did that. I just didn't write that. Like right here, what I did was do 2 to the what power equals 2. Oh, that's 1. And that's my answer, right? Because the answer to a logarithmic problem is your exponent. But like this work isn't needed whenever we're doing these. It's just, can you get here? If you still need to come to the side and do it, that's fine. But I'm not going to require you to show me this if you can turn it into the correct one. Does that make sense? Now, if you doubt your math and you think this might be wrong, show me how you got it so I can see where your train of thought is. Do you know what I mean? But it's not required. But technically, I'm using that change of base to solve these. Okay, let's do the quotient rule. The answer to a division problem is a quotient, right? I always misspell quotient. It's like my nemesis. So I'm actually going to write it here, so hopefully I have enough room. If we have log base b in parentheses fraction m over n, right? Just like with the exponent rules, if you have the same variables dividing, what you did was you kept the base and then you subtracted the powers. Here, the similarities is the fact that we're subtracting. So you take the base, the log of whatever base we're in of the numerator, and you subtract from it the log of whatever base we're in of the denominator. All those words made me tongue-tied. So you individually take the log of the top and the bottom and you're subtracting them, okay? So an example of this, say we have log base 4. Make sure, y'all, your base is your exponents. If they're little, it's very clear to me that you understand that that's not a normal size 4, right? In parentheses, 16 over y. Because these are in a fractional form, I know the answer is going to be a quotient. So I can apply this rule right here. And it says to take log of whatever base we're in of the top minus log of whatever base we're in of the bottom. So literally, log of, we're in base 4 of 16, making sure to write those ones little, ones big, right? Subtract from it log base 4 of y. I notice that I can evaluate this using the exponential form. I don't have to write it, but I can evaluate it, right? It would not stay in this answer. Leaving it in this answer is not the correct answer. Like you don't get all the points here because it's like not simplified enough technically. This is saying 4 raised to the what power is 16. So it would just be 2. That turns into 2 whenever we actually evaluate it. This is saying 4 raised to the what power is y. We don't have a power that's going to turn like this number into this variable. So it is just negative log base 4 of y. That's your answer. Okay, so if both of these I couldn't raise to a power to evaluate it, and that would just be the answer. Do you see what I'm saying? But because I could evaluate this one, I do evaluate that one. Okay, let's do this one. Say we have log of, okay, there's no base written. In the numerator, I've got 3x plus 5. In the denominator, I've got 10. The main thing I just need to notice is that this is a fraction. So it's like the top divided by the bottom. I apply the quotient rule. This is the one that I was asked about whether or not you could put it in your calculator. So I actually put it in my calculator and I got 0.544029 something, right? But my answers are going to be written in this form with the log, with the base, with variables. How it even came up with this, I don't know, because it didn't, how did it even know what x was? You see what I'm saying? So you can't use your calculators here. What we would do is we take the log of the base that we're in of the top, subtract the log of the base that we're in from the bottom. In all honesty, the way I would remember whether to use positive or negative with multiplying or dividing is that looks like a big minus sign, right? So I'm literally doing log base 10 of this minus log base 10 of 10, okay? And you could go ahead and write your base just because I think when it comes to seeing whether or not you can evaluate it, I think having that 10 like helps. At least make it more clear. You know what I mean? That first, that left-hand side, right? Log base 10 of 3x plus 5 is just log base 10 of 3x plus 5. We don't know what power I could raise that to get this as an answer, right? And in your answer, you don't have to write 10. Okay, I usually don't. And this one I did, but it's okay if you don't because it's 10. Y'all, if it's 2, 3, x, y, z, j, k, you have to write that. But when it's base 10, you don't, okay? This one, this is saying 10 raised to the what power equals 10. So it's just 1. That's your answer, not 0.544029. Do you see what I'm saying? That's incorrect. This is correct. Okay. We're going to do the power rule. I guess a fourth thing written on the board in case we needed to refer to it, okay? The power rule states that if I have, I'm going to write it here, log base b, that's an ugly b, y'all, but that's a b, right? My base is b. That's what b stands for, is base, log base b. And then of, I have m to the p. That p is a power, so I'm using a power rule, right? What happens, or not what happens, but what you do is this power comes out in front and is now a coefficient. So we have p log base b of m. That's the power rule. And I have 2 examples for this power rule. The first one is log base y of x to the 4th. And it should be very clear which one's your base, which one's your exponent, which one's written normally. Do you see what I'm saying? You can't just write them all the same because it's 100% wrong, right? Like effort's got to go into the way you actually write your problems. Okay, so I noticed that I don't have like a 2x to the something. I'm not having things multiplying. I don't have things dividing, but I do have something that has a power. And if something has a power, that power actually comes out front as a coefficient. Everything else remains the same. That's like a little scribble right there, y'all. So there you go. Do you see how I had 4? That was my p. But my p comes out in front. So 4 just kind of moves out into the front. And y'all, hopefully it's obvious, but it is very important that you know, if you have it in this form, you can write it in this form. If you have it in this form, you can write it in this form. It just really depends on what the problem tells you to do. But that equal sign literally means you can go both ways. Like they're equivalent. They're the same thing, okay? It's just like a different form. Okay, like literally that's it. If you see this, like that's the answer, okay? So I pulled this one from the homework just because I was afraid that it might be like kind of confusing. It is, you know, follow me. I even did the fancy cursive, natural log. Okay, it is the 11th root of x. So remember your root, like when you're with your radical, right? Your radican, actually. Your root is right there. I get another scribble. If there's nothing there, it's a square root. If it's 3, it's cubed. If it's 4, it's fourth. If it's whatever number is there, that's the root you're taking, right? So this is the natural log of the 11th root of x. So, okay, she told me about some product rules. When things are multiplying, I can individually add them, right? When things are dividing, I can subtract them. And if there's an exponent, I can bring it out front as a coefficient, right? This doesn't really look like any of those, but I remember that I have that exponent rule that says if you have a base, right, or just a variable raised to a power, an exponent that's in a fraction form, that's the root. The denominator's the root, right? So do you agree with me that if I have x to the 1 over 11, isn't this the fractional power that I told you allows you to take the 11th root of whatever's here? So recognizing that form and knowing your exponent rules allows you to see that, oh, this is a power rule. Because now I have a power, it can come out front as a coefficient. Y'all see how important these rules are? That's your answer. And just because I love you all. This was the rule that we learned. A to the m over n. A raised to a fraction meant that your nth is your root. A to the your m is your exponent. If you ever hear someone talking about the root of something, it's always the nth root. Your n meaning, is it a cubed root? Is it a fourth root? Is it, so knowing that it's the nth root, if you see a fraction, it can be written like this. So that's what I mean by that equal sign. You can go either way. I had it written like this. I remembered this rule. I wrote it like this. Oh, that's a way easier thing to see that it's a power. Now let me bring it out front as a coefficient. Puzzles. It's a whole bunch of puzzles and patterns, okay? So the actual answer would be right here. I brought that exponent out to the front. There is no other way to evaluate this any further, okay? Oops. I told you I was going to forget to square things off. Anyways, okay, so that's it. Now what we're going to do is actually combine these rules together. And you can see like the way a problem would look on the homework and the way problems would look on the exam, okay? These blank, boom. So we're going to combine rules. I haven't gotten or really looked per se at an old exam 3. Is this 4, 3? How many exams have y'all taken? Is this 4? Okay, it's my other class. They have 4. Thank you. Exam 3. To know exactly what the directions would say, right? I assume that like your homework may say like, you know, apply the like appropriate rules, right? It could also use the word expand and condense. So expanding means you start with something small and you're making it bigger, right? And then if it says to condense it, well, it's starting big and you're making it smaller. So like that would kind of be your hint as to what you're doing. But the goal is to just know if it's multiplying, I can add them. So if they're all adding, I can make it a multiplication problem. Do you see what I'm saying? It's like going back and forth. Let me see. Just in case something doesn't say specific words, I'm trying to give you all the words that mean what to do. This specific, what's that word? This specific problem, we're going to expand. Okay, say we have log base 2, and it's a really ugly fraction, okay? So in parentheses, in my numerator, I have a 4, and then in my denominator, I have the square root of x plus 9. Then these are actual homework problems that I pulled, okay? So what you need to do is recognize that because it's written as a fraction, right? This divided by this, that's the quotient rule. That's that big minus sign. I take this of the numerator and I subtract from this of the denominator. So go ahead and write that. Log base 2 of 4 minus log base 2 of the square root of x plus 9. I don't really like I feel like they get confusing here. And then what we're going to do is individually look at each of them and see, can I evaluate it any further, or is it just going to stay what it is, right? Just like we did with the other previous examples. If you look at log base 2 of 4, And you remember what we did on Monday and Wednesday, you know that what this is saying is 2 raised to the what power is 4. It's 2. So it changes to 2. Its answer is 2. And then if you look at the right-hand side, recognize the fact that it's in a radican, right? It's got the square root. The only thing that I've learned when I have something written in this form is that I can make this an exponent that's a fraction, right? And this is the square root. So my denominator would be 2. This is the same thing as that. Because using that rule I wrote on the previous page, if you have an exponent that's a fraction, your denominator is your root. Y'all, you don't write 2 and then the radican, right? If there's nothing there, it's understood that it's a square root. Okay, so now I'm going to look at this again. I've got 2, got minus. This would now be a power rule. So any radicans that you see, turn them into fractional exponents. Now you have an exponent, right? Or a power, which means that power comes out to the front. We get 1 over 2 log base 2 of x plus 9. Because just the power, right? Whatever was inside or whatever that was the power of, it just stays what it is. That's your answer. And this is why you can't use calculators for like these problems. Does that make sense? Kind of applying the rules a little bit? Yeah? Okay. Now we're going to go the other way with it. I know that this is like a big answer because I've got operations, right? I've got a minus or I've got a plus. And I know that it started like with 1 log, right? And I end with multiple logs. So it was small and I went big. Now we're going to start big and we're going to go small. So this would be what you would call condense, which just means to make smaller. And say what we have is log of y plus 14 log of z. Now, if you look at this the way that it's written, I know that that base is 10, right? And I know that 10 can't be raised to anything to get y. And I know that 10 can't be raised to anything to get 1. So there's no reason to like even include it in this one. Now, if you did have like 100 or you had certain numbers and you thought maybe, then you could. The only thing you need to recognize here, this one, like I said, I can't raise 10 to any power. So it's just log y, log of y. This one, right? Got my plus. If this is a coefficient in front of a log, it came from being an exponent, right? It came from being a power. So you write log z to the 14th power. So it's kind of like we're going backwards, right? This is what I would have had to have started with to bring it out front as a coefficient. So I'm going backwards in a way. I'm going to go down. Looking at my rules over there, I'm pretty sure it's the second one, top left. If you look on the right-hand side of the equal sign, don't I have a plus sign, right? And that came from originally, go to the left-hand side of the equal sign, them being multiplied. So because I have a plus sign here, that means that I can make this even smaller, right? Go from having 2 logs in this expression, honestly, not an equation, but this expression, to having 1 log, right? I'm condensing it, I'm making it smaller. And because of this plus sign, that tells me that these were being multiplied. So I would have log of y times z to the 14th. Use parentheses, don't use parentheses. Like, I mean, as long as here, you have to use parentheses, y'all, right? This is a power on 2 things. You need to show that. Here, this is just 14 on the z. If you had them written or if you don't, I mean, either is okay. Honestly, for continuity, if you like to write parentheses, write them all the time, right? As long as you write them in the correct place. That's your answer. And the way you can check yourself is to actually work backwards, right? Because usually this is how you'll see the rule. Well, these are multiplying. Because they're multiplying, I can take log of each of them, right? And what I can do is add them together. And then now let me work this way. Oh, okay, the power rule. That's a power. I can bring it up front. Okay, that's where it came from. Do you see what I'm saying? Like there's a way. You don't need a calculator. You just need to understand the rules. There's a problem. I mean, I think it's fun. Oh, y'all can't see it. Of course you can't see it. You can't see it. So it's 1/6, and then it's bracket 5 natural log of 5 plus 2 minus natural log of x minus natural log of 5. I'm sorry, x squared minus, do you see what I'm saying? That's a homework problem. Okay, and what you do is we're going to evaluate inside of here, kind of follow PEMDAS in a way, you know, and then I can condense it more. And then I notice it's a quotient problem. Then I notice because I've got a 1/6 out here, that's the power. And then I notice because it's a power, it's actually the 6. Do you see what I'm saying? I'm going to do a video on this one, like as soon as I get home, so that y'all don't like hate me whenever you do your homework later. Okay, but time-wise, we don't have time to do it. Okay, change of base property. So last thing we're going to do today, and then you can do your quiz and go home. Oh, I'm going to go over a compound interest problem after class. So if anyone wants to do that, we can. I'm just going to do it either here or there. I think we just moved along in the material. So like I never covered it and I haven't done a video over it. So like I want to cover it and I will do a video. I just haven't yet. Change of base property. To my knowledge, if there's a problem that needs you to do this, it'll actually say use the change of base property. I think there might be 2 or 3, like there's a handful at the end of the 4.3 homework. If you look at the help, I think it kind of looks confusing. And if you look at the packet, because that's all from the book, sometimes that also can look confusing. The easiest way is just to literally solve a problem and show you what it's wanting you to do, okay? The change of base property says if you have log base b of m, and it wants you to actually solve this, like give the approximate like decimal answer of this. What you do is you actually take log base a of m over log base a of b. So those a's here in this formula, they're 10s because we're going to use our calculator. The only way you can use a calculator for these problems is if your natural log has a base of e, right? Not a 2 or an x or a y, or if your common log has a base of 10. We have those buttons, right? We just don't have the buttons for the other problems where it was like base 2, base 6 or whatever, right? So what this is saying, and what they'll say in the help, is to take log of your big divided by log of your little. So I think that's pretty ambiguous. I don't know if they're saying your big number here, because like it's written big, and then your little number is your base, or they actually mean the values are greater. It looks like the values might be different. Maddie? 10. That's what I said. Yeah, the A's here are saying 10 because, and the reason why it's known, or you know this, or it makes sense that it's 10 is because it's telling me to use my calculator, right? The common log is base 10 and the common log's in our calculator. We can't use our calculator on the other problems because they have like base 2, base 4, base, right? I can't put those in my calculator. But if I can use my calculator with the log button, it's because the base is 10. So this is what you do. Say it tells you to evaluate it or approximate it. I'm pretty sure it would say use the change of base. Like that's just what makes sense. But say it's log base 16 of 86.5. Already you should know I don't have a way, especially not just, I mean, unless you're like a brilliant, to come up with a decimal answer that would be my exponent to get 86.5, right? Like I can't do the change of base and I can't do that. But because it tells me to use my calculator, I know that what I can do is write it in this form right here. And what you do is just log, this is your M, right? M. So log of 86.5 over, and then log of, that's my B right here, right? That's my little base. Log of 16. I should have maybe looked more, read more. Again, it'll say big over little. Are they saying because that's written big and this is written little, or because this value is larger and this one's smaller? Like, I'm not sure. I just know that I'm going to take log of this number right here divided by log of my base. In the other form that we're used to, y'all, this is your A, right? But they use A here for your base. So that's why I'm saying like it could look confusing if you go to the help, okay? So literally, I'm using my calculator, and it's a decimal, which means it's approximate. It's not exact. If it tells you to round it to 4 decimal places, literally what you do is you open up your calculator and you type log. It has a parenthesis, right? There's no base because it's 10. And you type in 86.5, close it. Okay, don't just hit divide, because now your order of operations, your calculator is going to either give you an error or it's just going to be the wrong answer, right? Go ahead and close your parenthesis. Then do the divide symbol. Then type log 16, close, and then hit enter. It gives you 1.608657, right? That's our answer, okay? So we've got 1.6087 if it told me to round to the 4th decimal. Now, I'm going to do one more example so y'all can start your quiz. Say we have log, okay, y'all, its base is pi, okay? Literally, just draw your pi of 72. And you see how even in this example, y'all, this value is larger, bigger than this value? Like, so that's why I'm still unsure. Is it because it's written big and that one's written small, or is it because this is bigger number and this is a smaller number? I don't know. I'll know on Monday. I'll look at it. Log of this one divided by log of your base. Log of M divided by log of your base is approximately, so log second caret, right? Because your caret, there's a blue pi. Nope. I started doing it wrong. Log 72, that's the top one, divided by log, now you do second, now you do caret, and you get your pi symbol. And then if you hit enter, you get 3.73596, whatever. It'll tell you what to round it to. It said 4 decimals, so 3.7360. In my lesson plans, I usually try to follow the homework. So if you're at the end of the homework, it's going to be one of those end problems I did that should correlate with the work you need to do it, okay? Okay, y'all. So do this quiz. Piece of paper, name, date, and then you are free to go. I'm going to zoom in as much as I can, okay? I know it's ugly. Whoop. I might have to write it somewhere I don't know. I made one that was actually probably a little too complicated, so I didn't do that one. I scribbled out that chunk. Okay, this says condense. These two right here, and then change of base, round to 3 decimal places. And that's log base 4 of 6 plus 2 log base 4 of x. And I didn't say this in the lesson, but I can only condense and expand and do stuff like that because these bases are the same. Okay, that's also a very important thing to know. This says change of base. It's log base 5 of 8. So you do log of 8 divided by log of 5, right? Because that was the change of base. And round 3 decimal places. I literally just told you what to do on question 2, so it shouldn't take you long. Y'all have got like 6 minutes. And when you're done, just come sit it on the stage.